Namaste student, welcome back to S block elements. In this video I am going to explain part 2 of S block elements, that is alkaline earth metals. In the previous video I already explained characteristic properties of alkali metals. So the properties are repeated even for alkaline earth metals. Now group 2 elements. Now S block elements. What is the meaning of S block elements? Here the last electron enters into the s orbital of the valence shell. So this is called as a S block elements. So in the periodic table the first two groups are belongs to S block. Okay, so group 1 it is called as a alkali metals, group 2 called as a alkaline earth metals. Okay, now I already given the explanation for alkali metals. Now I will explain what is the meaning of alkaline earth metals. Now alkaline earth metals, maximum metals are found in earth crust. Okay, so that's why it is called as a alkaline earth metals. Now general electronic configuration of group 2 elements or alkaline earth metal is that is noble gas. Okay, so noble gas NS2. So the group elements, okay, are beryllium, magnesium, calcium, strontium, barium and radium. Radium is a radioactive element. Alkaline earth metals as it is, that is even alkali metal also. Same way, alkaline earth metals do not exist in the form of an elemental state or free state. Always it is in the form of a combined state. So you can see the different ores. You can see the picture of different ores. Okay, so here the magnesium ore, that is a magnesite. Okay, and even magnesium ore, one more it is a dolomite, magnesium ore, one more Epsom salt, and calcium ore is a limestone, marble, okay, chalk, gypsum is also ore of calcium, okay, and fluorspar also ore of calcium. Okay, so it is a, you can see the picture. Strontium, barium, how it looks, and it is in the form of a ore. Now next you can see the picture of different ores, that is a dolomite, it is a ore of calcium as well as a magnesium, and you can see the picture of Epsom salt. Okay, Epsom salt, this is Epsom salt. Epsom salt, it is a ore of magnesium sulfate, MgSO4. Okay, and then here you can see ore calcium, ore of calcium, okay, limestone and marble, chalk, all these things. The next one, the characteristic properties. Okay, now first one, it is electronic configuration. Now what is general electronic configuration of S block elements? This is I already explained, that is a noble gas NS2. Okay, this is a general electronic configuration. So beryllium symbol is Be, atomic number is 4. So based on that 1s2 2s2. Which noble gas comes in this? Helium, because atomic number is 2. So it is helium 2s2. Okay, so one by one you can see the electronic configuration, and here in this electronic configuration which point you can identify, that is a outermost shell, that is here 2s2, 3s2, 4s2, 5s2, 6s2 and 7s2. So based on that general electronic configuration of alkaline earth metal is NS2. Okay, so the next properties, atomic radii and ionic radii. Now here also like alkali metals, ionic radii or atomic radii of alkaline earth metals increases down the group. increases down the group. Why it is increases down the group? Based on the electronic configuration. Okay, see here what happened. Down the group, atomic number is increases. So here you can watch it. Okay, atomic number is increases, and based on that the number of shells are increases, 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. So based on that what happened, as a principal shell or circles are increases, the distance between the center of the nucleus and outermost shell becomes more and more. So effective nuclear charge is decreases. So based on that concept, atomic size or atomic radius as well as even ionic radius also increases down the group. Okay, but now if I compare with the alkali metals, anyhow the properties of alkali metals I already explained. Now just I am comparing with respect to alkaline earth metals and alkali metals. Now here this is alkali metals and alkaline earth metals. This has come across the along the period. So along the period what happened to the atomic size or atomic radius? Along the period, atomic radius or atomic size or ionic radius is decreases. So based on that, alkaline earth metals are radius of alkaline earth metals are smaller. Okay, radius of alkaline earth metals are smaller than the alkali metals because of the increase in the effective nuclear charge, because of the increased effective nuclear charge or nuclear charge along the period. Okay, here you have to apply the concept of variation of atomic radius along the period. Okay, now the next concept, that is ionization enthalpy. So ionization enthalpy, what is the meaning of ionization enthalpy? That is amount of energy is required to remove the electron from the outermost shell. Okay, so here ionization enthalpy of generally for alkali metals, what I explained, that is generally alkali metals has a low ionization enthalpy. Same way even alkaline earth metals are also has a low ionization enthalpy generally when we compare to the elements of other elements of in the periodic table. Okay, now down the group what happened? We'll see down the group. Okay, that is from beryllium to radon. Now here what happened, ionization enthalpy, it is decreases down the group as atomic sizes increases. As atomic sizes increases, what happened, the outermost electron is loosely bound to the nucleus. Okay, so easily we can remove the electron from the outermost shell as we move from beryllium to radon. Now next comparison with the alkaline or alkali metals. Okay, so alkaline, I already told that generally ionization enthalpy of alkaline earth metal is very low because of their larger size. Even alkali metals also generally it has a low ionization enthalpy because of their larger size. But in the case of first ionization enthalpy, now what is the meaning of first ionization enthalpy? First ionization enthalpy means it is nothing but a removal of the first outermost electron. Okay, first outermost electron. Now in the case of alkali metals has one electron in the outermost shell. Alkaline earth metal has 2 electron in the outermost shell. Okay, now here the statement is given as first ionization enthalpy of alkaline earth metals are higher than those of alkali metal. Okay, now here in the case of alkali metals, it contains only 1 electron in the outermost shell. Okay, so this is easily we can remove. Okay, but in the case of alkaline earth metals, outermost shell contains 2 electrons. Okay, so it is completely filled in the s orbital. Since it is completely filled, it is not so easy to remove 1 electron from the s orbital. Okay, because it is completely filled. So based on that, the first ionization enthalpy. First ionization enthalpy means it is nothing but a removal of first outermost electron. That is called as the first ionization enthalpy. So based on that, first ionization enthalpy of alkaline earth metal is more higher than the alkali metals. Now what about second ionization enthalpy? Now second ionization enthalpy, what is the meaning of second ionization enthalpy? Second ionization enthalpy means it is nothing but a removal of second electron from the outermost shell. Second electron from the outermost shell. Okay. Now in the alkali metals, once I remove this ns1 electron, so nothing is remained in the ns orbital. Okay. Once I remove one electron from the ns, nothing is remained in the ns. Okay, and outermost shell. So outermost shell is empty. But in the case of alkaline earth metal, one electron is remained in the outermost shell. Okay. Now if I take example as a lithium. Okay, lithium alkali metals, that is 1s2 Okay. Now in the case of alkaline earth metal, beryllium is a alkaline earth metal, that is 1s2 Okay, so I will write it again. Now in the case of lithium is 1s2 beryllium 1s2 Okay, now the first electron is easily removed. This easily removed. That's why alkaline earth metal has a first ionization enthalpy of alkaline earth metal is greater. Okay, this is alkaline earth metal. This is a beryllium. Okay, beryllium. Now this is lithium. Now here. Now once I remove this electron from the 2s orbital, now which is present only 1s2 of the lithium. Okay, here in beryllium 1s2 2s 1 is present. Okay, now second ionization enthalpy, that means that is electron from the removal of electron from 1s2 orbital is very difficult compared to electron from the 2s1. So 2s1 electron is easily removed. Therefore second ionization enthalpy of alkali metal is very high compared to alkaline earth metal. Okay, compared to alkaline earth metal. So this is explanation. So you have to remember this concept. This is very important for the competitive examination purpose. That is, first ionization enthalpy of alkaline earth metal is very higher than those of alkali metals. Second ionization enthalpy of alkaline earth metal is smaller than the alkali metals. Okay. Now this is about the ionization enthalpy. So next property, that is hydration enthalpy. Now this hydration enthalpy concept is also I already explained in the alkali metal. Okay, hydration enthalpy means it is nothing but a reaction with the water molecules. Okay, now hydration enthalpy, how it varies? Hydration enthalpy is inversely proportional to hydration enthalpy is inversely proportional to size of the cation. This is I already explained. So that is cation size of cation is very smaller, means its hydration enthalpy is very higher. Okay, so based on that, beryllium has a high hydration enthalpy. Beryllium has a high hydration enthalpy because of size of beryllium is very small. So based on that, beryllium has a high hydration enthalpy. Okay, now compared to the alkali metals, hydration enthalpy of alkaline earth metals ions are larger than those of alkali metal ions because of the smaller in size. Now comparing with the alkali metals and alkaline earth metal, alkali metal is larger in size compared to alkaline earth metal. So based on that, what happened? I already explained that hydration enthalpy is inversely proportional to size of cation. So based on that, alkaline earth metal has a higher hydration enthalpy compared to alkali metals. Okay, so in the case of alkali metals, only lithium chloride has exists in the form of hydrated salt. Okay, but in the case of alkaline earth metals, magnesium chloride and calcium chloride exist in the form of a hydrated magnesium chloride salt as well as hydrated calcium chloride salt. But in the case of alkali metals, sodium chloride and potassium chloride do not form such hydrates. Okay, only in alkali metals only lithium chloride forms a hydrate. Okay, but in the case of alkaline earth metals, magnesium as well as even calcium also forms a hydrated salt. Okay, so that is only the thing is hydration enthalpy of alkaline earth metal is more compared to alkali metals. What is the reason for this? Because the size of alkaline earth metal is smaller than the alkali metals. Okay, so the physical appearance. Now how it looks. Even alkali metals, like alkali metals, alkaline earth metals are silvery white. Okay, it's usually soft metals. But compared to alkali metals, it is harder than the alkali metals. Now melting point and boiling point. Okay, so melting point and boiling point of alkaline earth metal, usually it is higher than the alkali metals. Usually it is higher than the alkali metals. Why? Because of the small size. Alkaline earth metal is smaller in size compared to alkali metals. Therefore, its melting and boiling point is higher than the alkali metals. Okay, and when compared to down the group, what happened? Melting point and boiling point is decreases down the group with respect to alkaline earth metal, because as the size increases, the force of attraction between the outermost electron and nucleus, it is weak, so easily we can break the force of attraction. Okay, so melting point and boiling point down the group, it is decreases with respect to alkaline earth metals. But if I want to compare with alkaline earth metals and alkali metals, alkaline earth metal has a higher melting point and boiling point compared to the alkali metals because of a small size of alkaline earth metals. Okay, and even in alkaline earth metals, how many electrons are present in the outermost shell? 2 electrons. So it will so much more amount of temperature is required to break the or to remove the 2 electrons. But in the case of alkali metals, only 1 electron is present, so it is easily broken with the little amount of temperature. Okay, so bond is strong in the case of alkaline earth metals. So the next property, electropositive nature. Now electropositive nature, what is the meaning of electropositive nature? Electropositive nature means metal has a capacity to donate electron. Okay, metal has a capacity to donate electron, that is called as a electropositive nature. Electronegative nature means it is nothing but a metal has a capacity or element has a capacity to accept the electron. So that time negative sign is formed. Now electropositive means element which is having a capacity to donate a electron. Okay, so both alkali metals and alkaline earth metals are electropositive in nature because both will donate electrons to the other species. So easily we can remove the electron from the outermost shell in both the cases, that is alkali metals as well as alkaline earth metals. Now alkaline earth metal is strongly electropositive in nature due to their low ionization enthalpy. Electropositive character is increases down the group because size is increases. Okay, and then flame coloration. Now here beryllium will not give the flame. Okay, so calcium, strontium and barium, only three element shows a flame coloration. Beryllium and magnesium do not impart flame coloration because of their high ionization enthalpy. So easily electron will not come out from the shell, so it will not give any coloration. Okay, the reason is given. You can see beryllium and magnesium do not impart flame coloration because of their high ionization enthalpy. So electrons are strongly bound to the nucleus. Okay, because of this, electrons are strongly bound to the nucleus and they do not get excited by the flame energy. Okay, but in the case of calcium and strontium, barium, electrons will excite. Electrons get excited by the flame energy. Okay, so what are the colors? Calcium will give brick red, and strontium crimson, barium apple green. Okay, so here you can see the color of calcium, strontium and barium. The next one is chemical properties. Now reaction with air. Magnesium react with air, that is oxygen and nitrogen, to form a magnesium oxide and a magnesium nitride, as well as even alkali metals. Alkali metal, lithium forms a monoxide. Okay, other alkali metals forms a superoxide and superoxide and peroxides. Same, even lithium also forms a nitrides, but other alkali metals will not will not react with the nitrogen. Okay, so reaction with water. Here calcium, strontium, barium readily react with water to form a hydroxides. Okay, reaction with halogen. Here you can see that M means it is nothing but a alkaline earth metal. X means it is a halogens. Halogens means it is nothing but a fluorine, chlorine, bromine, okay, iodine. All these are called as halogens. Now when it is reacted with the halogens, it gives as a MX2. Okay, MX2 means, suppose if I take example beryllium react with the chlorine molecule to form a BeCl2. Okay, this is the way of writing the equation. Now reaction with hydrogen. So all the elements except beryllium react with the hydrogen to form a hydrides. You can see the reaction, general reaction have written. So example, that is I can take as a calcium. When it is react with hydrogen, okay, so calcium hydride is formed like this. So like this you have to write the equation. So reaction with acids. Alkaline earth metals easily react with the acid to form a salt, to give a salt, as well as along with this it will liberate or release hydrogen gas. Okay, liberate hydrogen gas. So here also you can see the equations. It will react with the acid, hydrogen chloride and sulfuric acid. So hydrogen gas is released. So these are the chemical properties of the alkaline earth metals. Now we'll move on to the next concept, anomalous behavior. Now anomalous behavior meaning I already explained in the previous video, that is in alkali metals. Okay, now here beryllium, it shows a different behavior than the rest of the alkaline earth metals. Beryllium shows a different behavior compared to rest of the alkaline earth metals. Now what is the reason for this different behavior or anomalous behavior for a beryllium? Because beryllium is extremely smaller in size. Okay, then it has high ionization enthalpy. Because of the smaller size, it has a high ionization enthalpy. Actually alkaline earth metal has it has a low ionization enthalpy, but beryllium, it shows a high ionization enthalpy because of the extremely smaller atomic size, and even as well as it shows a high hydration enthalpy. So because of these three reasons, beryllium it behave different, okay, or it shows a different behavior from rest of the alkaline earth metals. Okay, now diagonal relationship. Now diagonal relationship also meaning I have already explained. The properties of the first element of the first group is almost similar to the second element of the next higher group. So beryllium, it is the properties of beryllium is almost similar to the property of aluminum. So diagonal relationship between beryllium and aluminum, that means what are the properties are similar. So two elements have same electronegativity. The value of electronegativity for beryllium and aluminum, it is almost same, almost similar. Okay, now there is a difference between similar and same. Same means it is exact same, similar means it is somewhat same. Okay, so electronegativity, it is somewhat similar, and then both metals are resistant to the action of acids. Okay, it will not react with the acid, that is beryllium and aluminum will not react with the acid, and both metal dissolving by strong alkalis to form a soluble complexes. Beryllium and aluminum, both metals will dissolve in alkalis to form a complexes. Okay, so chloride of both beryllium and aluminum have a bridged shape. Okay, so these are the few properties which is similar with each other. Okay, now compounds of the now here a few topics are deleted from the syllabus, so only two compounds we are going to study this year about calcium compounds, that is a plaster of Paris. Okay, so plaster of Paris, you already heard this word POP. Okay, nowadays in the newly built house you can see the POP. Okay, decorated materials you can see. So POP means it is nothing but a plaster of Paris, or chemically it is called as a hemihydrate of calcium sulfate. Okay, the formula it is written, that is CaSO4. Okay, calcium sulfate half H2O. Okay, so this is a formula of plaster of Paris or hemihydrate calcium sulfate. Now how it is prepared? It is prepared by heating gypsum. Okay, so you can see the gypsum powder. This is a gypsum powder. This is a POP powder. Okay, now gypsum is heated. So you can see the formula of gypsum also, calcium sulfate. Okay, it is 2H2O to 393 Kelvin. It is heated up to 393 Kelvin. Gypsum is heated up to 393 Kelvin. So during that time what happened? Plaster of Paris is formed. Okay, now the temperature should not be exceed, or should not we should not be allowed to rise above 393 Kelvin. Okay, we should not heat more than 393 Kelvin, because if we heat above 393 Kelvin, the entire water molecules will be lost. Okay, dehydrated. Entire water molecule will be lost or dehydrated. That means entire water molecules are removed. Okay, here this entire water molecules are removed. So what happened? Resulting anhydrous calcium sulfate is formed. Okay, so anhydrous means it is completely dry. Anhydrous means it is completely dry. So dry calcium sulfate is formed. This dry calcium sulfate is called as a dead burnt plaster. Okay, dead burnt plaster. Once it is completely dry, it is no use. It is no use. Okay, so keep it in your mind while writing the preparation. The temperature is very important. So it is gypsum is heated up to 393. Equation is very important, and equation is also very important. Usually it is asked for 2 marks. Okay, how plaster of Paris is prepared. The next, what is the uses? So what are the uses of POP or plaster of Paris? You already maybe you are knowing it is used for producing molds for industries such as pottery, ceramics. Okay, molds. So here you can see the molding. So here you can watch the molding part. Okay, Then it is also used for setting broken and fractured bones in the body. So here also you can see this. Okay, you can see the picture, and for making statue models and other decorative materials, and even in the dentistry. See, decorative materials, and you can see the picture. See how it is used. So here also you can see. Okay, so it is also used in dentistry. So here statues, models. Okay, so here also dentistry. You can see the uses of a POP. Next important compound is cement. Okay, so what are the cement, manufacturing of cement you already studied in your lower level, so I am not going to explain. Okay, so what are the raw materials which is used in the manufacturing of cement? That is a limestone. Okay, limestone, clay and gypsum. Okay, now uses, it is used in concrete, in plastering, and in construction of bridges, dams and buildings. Okay, so thank you very much for listening the characteristic property of alkaline earth metals. Important questions I already given. Please read that important questions. Try to answer the important questions. Thank you.